Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the hexadecimal number to octal in C language. So yes, let us start. First, I share my laptop screen and fix the position here so you can watch better our video lecture. And here, Turbo C++, I double click and take some process, and now yes, is open ultra file menu, taking new file, and here our goal, write a program to convert hexa hexadecimal to octal number. So yes, that we have to convert. So first we can understand both number systems. So yes, you have to know hexadecimal is a 0 to 9 and A to F. So that is a base of 16. And octal is a 0 to 7. So that is a base of 8. And hexadecimal, that binary, that format is represent in 4 bits. And octal, that is a binary format representing the 3 digits, 3 bits, we can say that. So yes, we can better do some paperwork, and I give one example. So let us take, we can convert like 957. That is a hexadecimal 2. We can convert into octal number. So yes, step by step. So yes, first step, we can write the that appropriate digits. So here we can say that convert hexadecimal to first binary in 4 bits. Yes, 4 bits group. So you have to know. So yes, I first write like we have to 9. Yes, separate 9, then 5, and then 7. So here we can write. So you have to know 9. So 0 1 0 0 1. Yes, and then we can say that 0 1 0 1, that is a 5, that is a binary. And now 0 1 1 1, so that is a 7. So yes, that perfectly. And now what to do? So second step, yes, step number 2, then we can group. Yes, here we can define the group in 3 bits. Yes, 3 bits to binary. So that binary we can define in 3 bits, 3 groups. So we can easily, because that is an octal, so we can define. So I previously told you hexadecimal, that is a 4 bits, that binary represent, and octal represent in 3 bits. So yes, let us take. So here first 100, then here that 101. Yes, then here in fifth, remaining 0 1. Yes, and then we can say that so here first we can take these 3 bits, so 100, and then 101. So 01, yes, again that is a 0, and then remaining 333. So is a perfectly. And now step number 3, we can convert, yes, this binary to octal number. So yes, we have to write here directly. So you have to know. So 100, so that is a 4, then 101, so that is a 5, yes, and that is a, here we can say that is a 2, and here that is a 7. So that is a, we can find, yes, that is our result. So that is a, we can say that our 4 5 2 7. So that is a octal number. So that is a process we can find out. So yes, now I can write here. So 4 5 2 7. So that is, we can apply in our C coding. Yes, so I give multi-comment line, so your, that is a reference. So we can complete 4 steps, but how to implement in C programming? So let us check or start. So that is a two technique different, but I here write short logic. You can also go this means first you can take one input as a hexadecimal, then implement that hexa to binary, and then binary convert into the octal. That is a process. But we can also take a short technique. So let us start. First, I include our header file. So stdio.h and on your console input output, yes, and then we can take, yes, here that is a math, yes, so math.h. So here we can use power function, yes, and you can also take like in hexa. So you can means hexa first one separate the digit and then multiply 16 and upon 0. So that is the next that multiply fifth in 16 raised to 1 and then separate 9 and then multiply 60 upon 2. So that is also process. So let us take, we can now start our main logic main function and declare some variables. So first we can character hex because we have to hexadecimal number. So yes, here we can yes, so 1D array, and now we can take some integer array. So that is a perfectly, so that is a first is a I, then we can find the length and decimal. Yes, we can also convert in this technique as a decimal, and then decimal to octal. So assign to 0, and then clear the screen. Yes, you can also follow in that I give in as paperwork, but here short technique I can apply. So let us take, so first we can input, yes, that is our input. So let us take, so input is our hexadecimal. So enter any hexa, yes, decimal number. So that is a perfectly, and we can get s, yes, because it is a 1D array. So you can also scanf, but here that is alpine digit. So that is no any problem in, because that is only one word, means that is a alpine digit combination. So that is a better, we can use hex, and you can also x means get as function pass hex, and scanf function you can also use. Now first we can find our length, yes, because that is a 1D array. So yes, the length we have to not initialize. So I assign to 0, and then we can say that hex that is a of length, yes, and that we have to not equal to null. So you have to know every string here that is alpha and digit that consider string because that is a 1D array. So not equal to null, and length we have to plus plus, and then here is a semicolon. So what is this? That is a advanced feature of for loop. That is a null statement in C language. That I think you have to know. If you not, you can watch advanced feature in for loop in my one video lecture. So 7 advanced feature I explain in this my video lecture in my channel. So that is a null statement, and you can also write in the body of for loop and directly after parenthesis. So what to do? So this loop is just that is a, we can say that that is a placeholder. There is no any statement. So that is a called null statement, and that is a count our length. We have to find out our length of x, that 1D array, and now our main loop is start, and that we can I use a 0. Then we can say that x of I not equal to, yes, here again that is a null. So you have to know every string terminate with null value, and then I plus plus and comma we can length minus minus. So that is a perfectly, and now what to do? So here we can take one if condition. So that is a short technique I apply. So we can say that hex of greater than equal to 0. So first we can compare and logical and operator. So digit we have to take, and that is a less than equal to in single quote 9. So because that is a 1D array, so we can compare 0 to 9 first our digit, and then we can convert directly in decimal. So in my paperwork, I direct means converting the first hexa to binary 4 bits, and then convert in 3 bits binary number, and then convert binary to octal number. But here I directly use short technique. So yes, let us check how it's work. So here we can first, yes, that is a hexadecimal. So that is a perfectly. And now what to do? So here we can power. Yes. So let us check. So decimal. Yes. Now I can give the parenthesis of I and then minus. Yes. Here. So that is a we can 0. Yes, so that is a perfectly, and then we can multiply power function. So multiply power. So I already include the math and 16. Then length minus 1. So that is a by default that is a means there is here a 0 to 9. So we can hex. There is no any minus. So only minus 0, and then multiply 16 length minus that is upon 16 upon. So if any 0 to 9 digits, so we can previously I can told you separate your digit and multiply 16 and upon. So that is a length is upon that our length that we have to start uh, upon, because in reverse order we have to find. Yes, let us check. And now I can copy this. We can also take as a watch so you can understand better way. And now what to do? So here we can take as a capital A to F. You have to know that is a hexadecimal. Capital A to F. There are 6 digits that cover. And what to do? So here we can use again ASCII code, and that I can minus here. That is a 55 hex ASCII value. So that appropriate of the decimal number. Yes, and here yes, plus and equal, that is a compound assignment operator, plus equal. So that meaning DEC equal to DEC plus this statement. So I think you have to understand. And now last time we can copy over lowercase if user press in lowercase A to F. So we can also convert that appropriate decimal number. So K to F, not a capital but small, small a, small f, and that time we can ASCII value 87 minus, and then apply the power function. So that is taking appropriate decimal number. So here we can directly hexa to decimal and storing or DEC variable. Now what to do? So here I initialize 1, and we can now decimal to octal. So decimal not equal to 0. Yes, and you have to know very well. So here we can take as a octal plus equal to. So yes, you have to know decimal, and we can take modulo 8 because that is the octal. So that is a perfectly, and multiply I. Yes, and then decimal divide equal to 8. Yes, and then that take the position. So I multiply equal to 10. So that is a get the perfectly position. So yes, let us check. And now what to do? So we can print. Yes, that we have to find. So we can say that hexadecimal to octal number is, and percentage D, and print OCT octal. So let us check that we have to do in paperwork. So I can save this logic. Yes, and here we can save. So that file name we can say that hex underscore OCT and dot C. So that is a perfectly. Let us check first for any. So here we can take as a simple logic. So you can also take this long process, means convert first 4 bits. So that is a you can take as a switch case logic, and so many case you have to take in this. So like a 16 case, because that is a hexadecimal number. And again that is a octal. Again you can one take while loop or for loop. and then 7 cache to convert 3 digits, and then convert octal number. So that is a long process, but that I apply is a short technique. So we can directly hexadecimal number to decimal, and then decimal converting to the octal number. So that is a perfectly. So here we can use as a ASCII value. Yes, so that is I think better. So yes, I hope. Let us check. Yes, we can apply. Yes, there is one warning. And what is a? So yes, here that is a plus and equal. Yes, that is a remaining. So yes, now I think all are well. Plus equal. Yes, that is a short technique. Compound assignment operator. So DC equal to DC and then plus and this statement. So that is a full form. I think you have to know, understand. So any query, then write in comment section. Yes, that definitely I give the answer, but here I think you have to understand perfectly. And that is also you can watch in my, that is a 7 advanced features. So here we can cover 2. So that is a null statement, and here comma operator we can 2 part, increment decrement part, and also initialize you can help of comma operator, and also logical and or operator you can multiple condition take in the for loop. So that is all 7 advanced feature in for loop in my one video lecture in YouTube. So you can search advanced feature of for loop. So you can watch that video. So now, yes, there is no any error and we can run. Yes, that is a 957. So let us take 957. So that is a 4527. Yes, 4527. So that is our octal number. And let us take, we can put some alpha, so capital C, and we can pass one C1. So that is a 301. Yes, that perfectly. So yes, I hope you can understand. So let us check watch window and how that is a possible this logic in C language, and also we can test like one capital BC. So that is I can solve in paperwork. So yes, that I match in my paper. Yes, that 674. Yes, perfectly answer. So yes, how it's possible? So that is I think you have to know, understand perfectly, and you have to do some paperwork. So then you can get the idea. Like I again one paperwork for this. I open first multi comment line, and here first our input is 1 BC, capital BC. So you have to know we can first step converting 4 digits. So that is a 0. So triple 1 and 0. So that is a 1. That is a means binary of 1. And then capital B. So you have to know that is a 1011. That is a capital B, means that binary value. And then capital C. So that is I think you have to know we can take 1100. And now second step we can separate in 3 bits. So here 000, yes, that is, and then 1 1, yes, here 1 1 0. So 1 is here 1 and 0. And next step here we can take, yes, triple, yes, that is a 2 1 year and 1 year. And now last is a 100. Yes, so here that is 0 is 0. Yes, and then here you have to know that is a ASCII value of 6, and here that is ASCII value of 7, and here that is ASCII value of 4. So that is our answer. I think you have to understand. So now let us check again, and we can take 2 examples. So I again give multi-comment line. So I not write all means step that name. So first step convert hexa to binary in 4 group. So we can just that hexa to 4 group, and then octal that support in 3 bits. So we can 4 bit group in converting the 3 bits, and then that binary means that binary to decimal means that value. So here that is we can get is a octal, yes, octal number. So yes, again I run. So we can give the 1 BC. So we can find out the 674, that is our answer. So 1 BC. So you can look 674, that is our answer. So how that possible in our logic? Yes, let us check. We can take as a watch window. So yes, alter W and watch. Yes, alter W and take output. Yes, and let us some decrease this our main blue screen, and we can set our watch. But first we can take yes here all variable in the declaration order. So hex, yes, first enter, and hex of I. Yes, that is our 1D array. Then we can take as the I separately. Then length, yes, we have to how find length, and decimal, yes. Then we can say that octal OCT. Yes, so all that is 4 is integer and 1 is a 1D array character data type. So now we can start our watch. Alter W, yes, that we have to take, an alter R, that is a trace into. So now I can start F7 function key. Yes, here our output window is now, and here we cannot means scan value, we can assign 0, and I and length we have to find, and X is there we can scan. So all garbage here you can look, I and length is a taking some garbage value. And now I can press else, so clear the screen. Our output is clear. Now again enter any hex number and we can scan. So first we can take 957. So that is our first paperwork. So let us how it's possible. So yes, here you can look, that is a just pass out. Yes, that directly take the length. Yes, there is a 3 because 957. So that is a 3 length, the digit length of. So that counting this for loop. And now what to do? So here I equal to 0. Yes, I initialize that not equal to null. So let us check 9. Yes, 0 to 9 in this first if is condition is true. So you can look, that is a power function length minus 1. So length is a 3 and minus 1. So 2 upon 16 and multiply minus 0. So there is no effect. So 9 multiply 16 upon 2. So that is a decimal number. You can look 200, 2304. That is a you can find. So you can take some calci. You can idea. And now here that if condition is false, yes, this if condition is false, and again that is a I plus plus, and length is minus minus, so that is a 2 and 5 digits. So again that first if condition is true. So yes, again length minus 1, so length 16 upon 1 multiply, that is upon power function, and hex, that is a remaining 5 because we have to minus the 0. Yes, that is a means decimal number 2364. So that is a plus. Again this 2 if condition is false, again I plus plus last time, and here that is a 7. Yes, last our digit. So 957, that is a directly take this loop. So we can take here not in reverse order upon, because that is a starting first. If we take 7, 5 and 9, so that is a upon we can 0, 1, 2, but here that is a in length we have to find in the um, perfect means first that is a length and then minus, so that is a perfectly. So yes, last time that if condition is true, and again that multiplication all. So I that we can use again in our that is a while loop. So I assign to 1 and decimal not equal to 0. Yes, we can convert decimal to octal, so that you can modulo 8 and multiply I. So initially I is 1 and divide by I that number. So that is a 298 directly, and then take the position. So again, that is a decimal, yes, not equal to 0. That is a modulo 8 and multiply I. And then again, taking 7, octal number 27, and then modulo 37 decimal, and then take position. Again, same process. Yes, now that is a perfectly. Let us check. So last time, yes, that is a not equal to 0, and now that is a 0. So we can find to our answer. And if any range problem, here you can look that I is a 10, yes, 10,000. So you can take in the long integer, that is a better. Okay, otherwise sometimes taking in negative. So I again press F7. So yes, look, that is a perfectly you can find out 4,527. That is our answer. So what is the solution? If any range problem is there, so here we can take as a I. Yes, I is a very long, that decimal and octal is not required. So I we can take as a long or long integer. That is a better. So yes, I remove, and here we can say the long integer I. Yes, let us check. And now we can take again, we can start our watch. Yes, so we can give now some digits, means alpha and digits. So that is our second paperwork, 1 BC. So how that go in second B, 2 if condition. So yes, that is a found in 3 length. Yes, and again that is a not getting this directly if condition first true. So that is a decimal. Yes, 256. Yes, because that is a minus and 1, so power that is a upon 2, and that is a 256. Yes, 16 multiply 16, so that is a 256. And now that is 2 if condition is false, now I plus plus, now B, so that is a capital B, so that is a second if. Yes, first time, so I take again time, second time watch. So here now that go and minus 50, so that is a ASCII value in minus and taking appropriate decimal number. So you can look 432. So we can solve, that is a power of minus 1. So that is a 1, and then multiply this value. So that is a minus ASCII value, that is a get exactly decimal number. So that is a capital, you can minus 55, and lower you can 87. So that I can minus. So you can do some paperwork. And now C capital. So again, that is a second if condition is true. And then yes, that is a 444. And now that all I initialize 1, and decimal 444, that converting octal. So look, now that is a yes taking position. And here there is I not taking any range problem. So I take as a long integer. Yes, that perfectly. And now last, yes, perfect. So 674, that is a 1 BC, that is a hexa to octal. So here you can also take some paperwork. So you can get how I can minus 55 in uppercase to convert that hexa to decimal, and here lower A to F minus 87. So how to get that ASCII value to decimal number. So I hope yes, here we can do some paperwork and apply to our logic in C language. So now that perfectly. So any doubt or any question regarding this definition, so you can write in comment section. I give the definitely answer to you, and write this program to your C notebook. And now I can close this file. Okay, Alt F3, watch and output window, and quit. So subscribe my channel Ashok Sijal Academy. Press the bell icon to never miss any update. Thanks for your watching, supporting, and sharing my video lecture. And Hare Krishna.